Now we are going to know general scalar spring. Hooke's spring law is also applicable to different types of elastic material or objects with random complexity. However, this will depend on whether the stress and deformation can be represented by a single number. This number can be either positive or negative. For instance, if we take a rubber block and attach it to two plates kept in parallel, it is distorted by shearing. So the shearing force Fs and the sideways displacement of a plate's x follows or adhere to Hooke's law, small deformations. Now, vector formulation. If we stretch a helical spring or compress it along its axis, then the restoring force as well as the resulting elongation or compression have the same direction. As such, when Fs and x are defined as vectors, then Hooke's equation will still remain valid, and it will states that the force vector is the elongation vector multiplied by a fixed scalar. Now we are going to know applications of Hooke's law. The applications of Hooke's law are as given below. Most commonly in everyday life, Hooke's law is applied in spring because of their elasticity. They are used not only in the engineering field but also used in the field of mechanical science. It is used in breathing, lungs, skin, spring beds, diving boards, and car suspension system. It is used as a fundamental principle behind the manometer, spring scale, and balance wheel of the clock. It is also used as the foundation of seismology, acoustics, and molecular mechanics. Now, disadvantages of applying Hooke's law. The disadvantages of Hooke's law are as follows. Hooke's law is applied only in the elastic region. Hooke's law gives accurate result only for solid bodies if the forces and deformation are small. Hooke's law is not a universal law. While we have learned in depth about Hooke's law, let us also understand the subsequent term which can be used inside the mechanical properties of solids. Let us quickly go through them. Important mechanical properties of solids: stress and strain. Stress, it is the resistance offered by the body to on any deformation. Mathematically, it can be expressed as the restoring force per unit area. Stress equal to restoring force by area equal to F by A. Strain, deformation per unit length in the direction of the deformation is known as the strain. Strain equal to change in length by original length, or delta equal to delta L by L. Now, plasticity. It is the belonging of material by which material does not regain its original dimension after the removal of the deforming forces. This material goes in elastic strain. In this case, permanent deformation occurs. Elasticity. Elasticity is the property by virtue of which a material deformed under the influence of load, but upon the removal of the deforming load, the object tends to recover its original dimension if the body completely regains to its shape, and size, it is called the perfectly elastic body. Ductility. It is the property of material which permits material to be drawn out longitudinally to a reduced cross-sectional area because of the application of tensile force. It can also be defined as the property of material which permits a material to be drawn out in the form of wired. Brittle, brittleness. It implies that material cannot be drawn out in the form of wire. The failure takes place without any significant deformation.